In this video, I'm going to cover how to use your formula sheet on the AP exam and what's important and what's not. So under descriptive statistics, not important, not important, not important. The likelihood that you use these remaining three formulas is pretty low. This would have to be where they give you the summary statistics, the mean and standard deviation for each variable, and they give you the correlation. If that's the case and they ask you to write the least squares regression line, you would do this first, take your answer for B, plug it in here to solve for A, and then substitute those in to get your least squares regression line equation. That's it. Probability and distributions. This is, remember, this is union, which means or. This is intersection, which means and. So this would be for use on a two-way table, but you don't have to use the formula. You can just reason through it. Same idea here as far as a conditional probability of A given B is the probability of the intersection divided by the probability of what's given. We didn't spend too much time emphasizing the formulas in chapter 5. The next whole part of this formula sheet, this is chapter 6. Discrete random variable. This is if you just have like something like this 0, 1, 2, 0.5, 0.4, 0.1, and you want to find the mean or the standard deviation. That's the formula you're going to use for these. Binomial, you'll notice it says there's the parameters n and p, mean, standard deviation, just following the columns. Geometric has one parameter p, mean, standard deviation. This is the formula to find like exactly. So there's 10 people, what's the probability exactly 3 are left-handed? This nx is n choose x. That's how many different ways that you could select 3 successes out of 10. And then geometric, same idea. Okay, so I would use this really, so far, the only thing that I'd be using is this middle piece realistically. All right, the bottom piece is awesome as long as you understand how to use the formula sheet. Anytime you do a standardized test statistic. So for any test we did other than chi-squared, you're going to use this. If you do a chi-squared test, this is the formula that shows you how the test statistic is calculated. The sum of the observed minus expected squared divided by the expected. And anytime you do a confidence interval, same thing. Every confidence interval we've done follows the same format. You'll notice a lot of similarities here. Statistic, standard error of statistic, standard error of statistic. And that's where the back is going to come in. The parameter is going to be your null value. And this critical value is going to be either inverse norm or inverse t to get that. So let's take a look at the back. This first column, make sure you know, I would label this first column statistic. This entire column all the way down the page, this shows you your statistic. And the top half is proportions, then means, and then for regression, which we just covered. So if you're doing any one proportion z-interval or z-test, that's your sample statistic. If it's two proportion z-interval or z-test, those are that's your statistic. Same thing. One sample t-test t-interval or paired t-test t-interval. Two sample t-test t-interval, and then this would be a one sample t-test or t-interval for the slope. So that's the symbol. That's what's going to go here. You don't need to use the symbol. I would encourage you not to. Just plug in the value or values. Now, the standard error of this statistic, it's just this last column. So that's it all the way down. Now, what I want to point out here, when P1 equals P2, so this is going to be for one proportion, z-interval, z-test. This is two proportion. The only time you're ever using this is for a two proportion z-test. That's it. For two proportion z-interval, you're using this. Two proportion z-interval. Why are we using this for the test? Because we're assuming the two proportions are equal. So we have to get that combined estimate, where this is like the number of successes in each group divided by the sample size. So say in group 1, it's 10 out of 30, and in group 2, it's 15 out of 25. I would do 10 plus 15 divided by 30 plus 25 to get that combined estimate and plug it into that formula. As far as the parameters go, this is what you should be using for your null hypothesis. This is the symbols for the null. Either P, or if you have two proportions, the difference between those. And then this is what you're going to use for a one proportion z-test, because we have a claimed value for the null. All right, moving on to means. This is if you have one sample. This is if you have two samples. One sample or paired. These are your nulls. If this is paired, it would just be the sample mean diff, mu diff, and standard deviation diff. All right, so that's going to be the symbol you use in your null, mu, and then the standard error, nothing fancy here. The top's going to be for the one sample, the bottom's going to be for the two sample. Just make sure you write it down correctly when you substitute your values in. The last one is going to be the one sample test or interval for the slope. That's your sample slope. This is going to be your null value, the parameter. And then realistically, you're not going to need to use these formulas. I would be shocked if you did. They'd have to give you quite a bit of information here. And then I just want to point out this little asterisk down here. Standard deviation is a measure of variability from a theoretical population. Standard error is the estimate. If the standard deviation of the statistic is assumed to be known, then the standard deviation should be used instead of the standard error. What the heck does that mean? Going all the way back up here. For one proportion z-test, we have some kind of claim for p. So instead of using the sample proportion, we use that claim proportion. So we'd be using the standard deviation instead of the standard error. That's why. So I hope this video made it helpful so you really understand how to utilize your formula sheet, especially the back of it when you're dealing with confidence intervals and tests on the AP exam.